Hello students, this is lecture number 26, okay, and we are into chapter 7. Okay. So, in last video lectures we have seen at the two kinds of elements. One was the rectangular element, the other was the square element. So, one element which has this kind of dimensions, where a and b are different, yeah, and the special case of that is when both are the same, and we have derived the stiffness matrix. So, K equal to F, K u equal to F, and we have derived the stiffness matrix K and F both, yeah, where u is the T matrix or the temperature vector. Okay, so today we are going to work on any arbitrary quadrilateral element, something like this 1, 2, 3, 4, and we are going to look at the ways, in how many ways we can do it. So, for this one very easy basically. So, being very straightforward because of this geometry, for this one it will be complicated. Okay. So, one thing which will be actually we are going to use for in this case is what is known as the isoparametric element. So, we will work on today isoparametric element, but before that if you have to find out this one, like you have to find out the shape function of this one, ultimately we are looking at the shape function. So, if you have to find out the shape function for this one, how will you find out? Well, so for that we know that the in general we can write for depending on the number of nodes you have, you can find out. So, for example, if you had say like a 1D case, right. So, then you have something like 1 x square x cube and so on to x n. So, if you have two nodes, then you will have n x equal to alpha 0 plus alpha 1 x. If you have three nodes, you can have n, let us say n I. Okay. So, n I x will be alpha naught plus alpha 1 x plus alpha 2 x square. So, this becomes quadratic. You add one more. So, then you will add alpha 3 x cube and so on, right. So, you keep on adding like this one. What happens in this case? Well, we can also have here the similar thing here is something called Pascal triangle. Okay, so you have like this, the triangle means, so you have a 1, then you have x, then you have y, and then we have x square, xy, y square term there, then you can have x cube term here, then x square y term, then x y square, then y cube term and so on, right. Okay. So, looking at that, you can compose accordingly. So, let us say you have the this 4 noded quadrilateral element, we are talking about 2D. So, we have like x and y, yeah. So, for that we can say we will have 4 nodes. So, hence 4 shape functions, and we can have like every of these n1 x y, you can write it as alpha naught plus, you can write alpha naught. So, we can also write like this one, alpha I plus alpha, not alpha but beta I x. So, we can select this one, these 4, yeah, why 4, these 4, because this makes it symmetric, right. So, we can take these 4 from there. If you take 1, 4 like this one, 1 x y and y square, something like this one, then this is more biased towards y square, means it the element will be quadratic in y but linear in x, not good. If we have this symmetric, yeah, so we have 1 x y and x y multiplies, so this makes symmetric in x and y both. Hence we can write this one as the alpha I plus beta I x plus gamma I y plus delta I, we can write as x y here like this one. So we can write the shape function like this one. Since there are 4, so there will be 4, so I equal to 1 to 4. So we can have this one. Yeah. Okay. Now if we have this, then how to find out alpha I, beta I, gamma, like this one? This we can find out by we know that n1, so let us say the coordinates here x1 y1, x2 y2, x3 y3 and x4 y4. Right. Okay, so then accordingly we can write we know that n1 will be at x1 y1 has to equal to 1 and n1 at x2 y2 will be equal to 0, will be equal to n1 x3 y3 is equal to n1 n1 x4 y4, that we know, right. So hence we can actually put those values here in this one and we can find out. So what we will find out is basically simply we can write it as n1, the values will be so simply we can find out, we can write like this. So 1 x1 y1 x1 y1, 1 x2 y2 x2 y2, 1 x3 y3 x3 y3, 1 x4 y4 x4 y4, right, multiplied by alpha I, beta I, gamma I, delta I. Basically here is I equal to 1, so basically I think we should rather write 1 2 3. So 1 alpha 1, beta 1, gamma 1, delta 1 is equal to 1 0 0 0. Okay. So this equation we get from here. So if you put I equal to 1 and you put first x1 y1 value here, means that corresponding to this one, you know that n1 will be 1 here and 0 0 0 all these others, and hence we are putting x1 y1 here first and this at I equal to 1. So we know n1 will be 1 at x1 y1, n1 equal to 0 at x2 y2, x3 y3 and x4 y4. Same value we will put, there will be 4 equations. And there are 4 variables. Which variable? Alpha 1, beta 1, gamma 1 and delta 1. Yeah. So for this we can find out, right. So we can get this value, and hence we can, let us say this is equal to a matrix C. So we can readily find out alpha 1, beta 1, gamma 1, delta 1 will equal to C inverse 1 0 0 0. Okay, now mind it that there is I equal to 1 to 4. So there are 4 of them, means 4 alpha, 4 beta, 4 gamma, 4 delta, right. That means total 16 variables. Yeah. So total 16 constants to be found out. by doing this one, we are just finding out just 4. So, we have now alpha 2, beta 2, gamma 2, delta 2 corresponding to n2, the shape function number 2. And you can do the similar analysis and you can find out that we have alpha 2, beta 2, gamma 2, delta 2 will be equal to nothing but C inverse 0 1 0 0. Now, this will be, earlier it was 1 0, but here is 0 1. Why? Because n2 is 1 at node number 2 and 0 at others. Hence, the equation will turn out to be like this. Similarly, this alpha 3, beta 3, gamma 3, delta 3 will be equal to C inverse 0 0 1 0. Yeah, and similarly, we can find out the other one. So, similarly, you can find out this last one. So, this is the alpha 4, beta 4, gamma 4, delta 4 will be equal to C inverse, and we will have 0 0 0 1. Yeah. So that means like you can find out this one. Once you have found out this, you can construct the shape function, all the 4 shape functions, all the shape n1, n2, n3, n4, you can find out that. But see, in order to find out, you have to invert once here, once like you have to invert this C, right. So, so inverting this one will take time. Consider in a case where you are discretizing one 2D domain into a number of irregular elements, then for every element it has to be inverted. Yeah. So, this is time taking, number one, and also that makes it little bit not elegant, you know. So, there is a cleaner way of doing the same thing, finding out the shape function and all, and that is what we will do. The alternative method is known as the isoparametric element. Isoparametric means the equal parameter. Okay. So, here if you see that the original some quadrilateral element, something like this one, 1 2 3 4, we are going to map into one square element. So, something like this one. So, here if it was x1 y1, x2 y2, x3 y3, x4 y4, this will convert into -1 -1. This is, here we had x coordinate system, x, not x1 but x and y, and here we will have xi and eta system, and we will have 1 -1 1 1 and then -1 1 system. Okay. So, we are going to map from here to here and do all the calculations in this mapped system. Okay. So, that makes life easier. Okay. Now, here we know that first of all we can write the relationship between the two can be in terms of shape function itself, meaning that, what is the meaning of that? Meaning of that is we can write in fact x as a function of like a shape function ni, which is a function of xi and eta itself, and then we have x1, the xi. So, I equal to 1 to 4 in this case. Okay. So, what is the meaning of that? Meaning of that is we can define a shape function. This is nothing but the shape function itself. shape function. Okay, we have shape function itself. So we are the way we define the way we define the test function, we are defining coordinate system itself like this one, and it works. It works. You can see that. Like, let us say that if you see here, this is let's say we have xi and eta equal to -1 and -1. Test xi 1 equal to -1, sorry, xi equal to -1 and eta equal to -1. Okay, so we are going to put the value here, and if ni, okay, if ni -1 equal to 1, okay, for I equal to 1, and ni -1 equal to 0 for I equal to 2, 3, 4, then what we are going to do? We are going to get x equal to x1. So x equal to n1 x1, n2 x2, n3 x3, n4 x4. Okay, now xi equal to -1, eta equal to -1, that really means this is talking about this one, x1, we are talking about this point. So what I am saying that if n1 is equal to 1, n1 is equal to 1 at this point, n2 is equal to 0 at this point, n3 is 0 at this point, and n4 is 0 at that point, then n1 times x1 plus n2 times x2 plus n3 times x3 plus n4 times x4 will be equal to x1 only, right? Okay, so this is how it, so that means it will work provided these n's are like shape functions, right? So these are actually this is how the shape function behave, right? This is the property that the shape function has. Hence we can write the coordinate system like this one. Similarly, we can also write the y like this. So y will be equal to like this one, n I xi eta, and then you have y I equal to 1 to 4, like this one, where we can define, we know that like if we have xi and eta system, this is -1 plus 1, okay, -1, then 1, 1, and then we have -1, 1. So we know that in this case that this shape function eta 1 xi eta we can give it as like xi -1 eta -1. Why? Because the value, this n1 should be 1 here and 0 on this one. Hence we have to figure out what is the equation of this line here, we multiply. So this equation is xi equal to 1, so xi -1 we are writing here. This is in eta equal to 1, so eta -1 we are writing here, and then divided by, we know that n1 has to be equal to 1 at node 1. So this is node 1, 2, 3 and 4. So n1 has to be 1 at node 1. So if you put -1 here, so -1 here, so becomes -2 multiplied by -1 here also, so -2 total 4. So we have to divide by 4. Similar analysis you can do as we have also done in the last lectures, and there instead of xi eta we had xy system, but we actually worked like this only, and you can do the similar kind of analysis to find out what is the value of n2, and what we found here, this will be something like this. So, the n2 here, n2 will be this one and this one. So, what we will find out, this is xi equal to minus 1, xi equal to minus 1. So, you get xi plus 1 and eta minus 1. Okay, so this eta equal to 1, so eta minus and minus 4, because if you put 1 here and minus 1 here, you get minus 4. So, hence you get multiply by minus 1 over 4, so that you have n2 equal to 1 at this point. Okay, similarly we can get n3 xi eta equal to minus 1, sorry, not minus, it will be plus only, over 1 over 4, xi plus 1, eta plus 1, n4 xi eta will be now minus 1 over 4, and we will get xi minus 1 and eta plus 1. Why? Because if you put this value minus 1 here and 1 here, you get minus 2 multiplied by 2, so minus 4, hence you multiply minus 1 over 4, so that you get 1. And this n4 will be 0 at this, on this line means nodes 1, 2, 3, all the 3, at these 3 nodes this value will be 0. Okay, so we got these shape functions, and now we can write like you can actually earlier we wrote the test function as a like value of the in form of the value of the u or displacement at these nodes. So, right now we are doing the x and y coordinate itself, we are interpolating, that is what is the meaning of that. So, if you know xi and eta, then you can find out what is the value of corresponding x and vice versa. So, that means let us say if you have to find out what is the value of x and y here, and then we can find out accordingly, right? Let us say at 0. Okay, so so if you want to find out what is the value of, say, equation, okay, question. Okay, so what is the value of x, y at xi equal to 0, eta equal to 0. So, you put all the values and you can find out. So, you can find out simply x equal to what do you get here? So, you put 0 and 0 here. So, you get minus 1 over 4. 0 and 0 here, what do you get? So, 0 0, so minus here, so 1 over 4, 0 0, 1 over 4, then again 0 0, we get 1 over 4. See, in all the cases you get 1 over 4 only. Okay, so x will be equal to simply 1 over 4 x1 plus x2 plus x3 plus x4. Similarly, y will be equal to 1 over 4 y1 plus y2 plus y3 plus y4. Yeah, and it makes sense, right? So if if have a quadrilateral something like this one, and at the middle, what is the value? So, this will correspond to, you add x1 plus x2 plus x3 x4 divided by 4 will give you the point, the value of x and y at this point. Yeah, so this is how it works, the interpolation not only for the temperature, but also the x y coordinate itself. So, note that we can also write test function t as a same kind of summation n I xi eta, and we have multiplied by Ti. So, that if we have we know the temperature at these nodes. So, we have T1, T2, T3, T4. So, we can write like this one. So, we have T1, T2, T3, T4. Then we can find out temperature at any point by using the interpolation functions. Okay, so if we have a T like this one, then we can now do the analysis. Analysis means we can write the everything in terms of eta n, n1, n2 of like eta and the xi and eta. So far we know that we have shape functions defined on the mapped coordinate system, and we have x also, x and y as a function of xi and eta, and t itself also as a function of xi eta, or based on this information we have to do the analysis. Now we have the weak formulation, we know that already, and from there we have to now do put these values from here, and accordingly we can do it. So from the weak formulation we know that we have the k times u form, right. So we have k u equal to f time of form, and where k is given by this equal to, we have b t, okay, then d b d omega. So that type of analysis we have done for any arbitrary number of elements, that we have done already. Okay. So this one for any arbitrary number of elements, for any arbitrary number of nodes. So how to find out k now? Okay. So k value, the first of all the b value itself, if you see where b is given by, okay, so b is, if this b will be 2 times n matrix, where n is the number of nodes. So this we have seen earlier. Okay. Hence we get n by n. If number of nodes is n, so you get n by n matrix, because this is n by 2 because of this transpose thing. So n by 2, this is 2 by 2, and this one is 2 by n. So you get n by n. Also we know that if d, we can assume here d will be equal to k times 1 0 0 1 for isotropic. Okay. Okay. So meaning of b, what is b here? Okay. So b is equal to, we have seen that this is 2 by n, and here this means del n 1 over del x and del n1 over del y, and so on, del n2 del x, del n2 del y, yeah, and so on till n. So del n del x, del n del y. So this is like this. Okay. Now that means we have to, if we have to find out b, we have to find out this one. So what is the value of this? Yeah. So we have to find out this one. What we know so far is the n which is a function of xi and eta. So, how do you find out the value of this? Yeah. So accordingly we have to do some mathematical operations to find it. Okay, so far we know n1, n2, n3 and so on. In this case n equal to 4. So, here n equal to 4, we have n equal to 4 here. Yeah, so we know that any ni del, if you have to find this one, so del ni over del xi, okay, we can write it as del ni over del x, okay, and then del x over del xi plus del ni over del y and multiplied by del y over del xi. Similarly, you can write del ni over del eta is equal to del ni over del eta, del x over del eta plus del ni over del y over del eta. Why we have done like this? So that we can get these values. Okay, and we are writing this way because we will get something known things. That's why we wrote like this one. I will see that. So next, if you go, then what we get? We get what we do see here, x over dx dxi. We have the same thing here and here, here and here. So we will have del ni over del x, del ny del y, and here you will get del x over del xi, del y over del xi, del x over del eta, del x over del zeta, del y over del eta, right. So okay, so we will recognize that what is the meaning of that. So what we get is right in the matrix form, and you get del ni over del xi and del ni over del eta will be equal to this, del x over del xi and del y over del xi as well. So del y over del xi, then del x over del eta and del y over del eta, and then here we have del ni del x and del ni over del y. Okay. So this is what is this one? This actually we know this as Jacobian. So write J, and this is for the particular elements, we can write it Je. So eth element Jacobian. Yeah. So this is for different element, this value will be different. Okay. So we can find out Jacobian. In order to find out Jacobian, first of all, which all value we know? Do we know this ni del ni over del eta? We know, because we know like ni, n1, n2, n3 and all n4, all of them are written in terms of xi and eta, hence we don't know exactly this one. Do we know this one? Yes, we know, because x is also written in terms of xi and eta, in terms of shape function itself, and shape function we know explicitly, hence this value is also known. This whole matrix is known. Do we know this one? No, this we wanted to know, and hence we did this one, so that we can construct the B matrix. So what we see here is simply we can say that like this. So del ni over del x and del ni over del y will be equal to this Je matrix, we see inverse of that, and then we have del ni del xi and del ni del eta, right. So this is what we got, this is the relationship, this is how we get this. Sorry. this one. Now, B matrix, in order to find out, for us B is till 4, n equal to 4 we have. So, n equal to 4. So, since we know this one, so we have to now extend and find out the whole B matrix in terms of this one. So, given this relationship, we can write B matrix basically, and the B matrix, which is we know that B x y is equal to we have del n1 del x, right, del n1 del y, to del n4 del x. So, del n4 del y, this is given by J E, Jacobian inverse of that, and B as a function of xi and eta, where B xi eta is given by this del n1 over del xi del n1 over del eta, del n1 over del n2 over del xi, del n2 over del eta, del n3 over del xi, del n3 over del eta, del n4 over del xi, del n4 over del eta. Okay. So, this is, since this is valid, hence we can extend that to B also without any problem. Yeah. So, here we have 2 by 1, and we have here 2 by 2, and then we have 2 by 1. Once we can extend that to this matrix, this one, meaning that simply B x y is equal to J E inverse of that and B xi eta, and we can do that because B will be 2 by 4 matrix in this case, and this is 2 by 2, yeah, and this is also 2 by 2. So, 2 by 4. Hence, 2 by 4, here also have 2 by 2 multiplied by 2 by 4, and hence you get this Bxy. So, this is how you get B matrix in terms of xy. You get basically this is equivalent to this one simply. Yeah. Okay. So basically if you see in the K, right, in order to find out the K matrix, and we needed B, and this is given now. B we know, hence we know this one. We have D and this. Now what is the meaning of that? That also we have to look at. So basically here we have like this one, B, right, like this one, and B transpose. So B x y transpose of that will be simply J E inverse and B xi eta transpose of that. So we get B xi eta transpose of that multiplied by J E inverse and transpose of that. This is how, that's what we will get. Okay, so we have got this one. So the K so far is given by B x y, transpose of that, D B x y and d omega, and this now we have to change basically. So what we have got so far is equal to omega, yeah, and then omega in this case now, since we are going to transform from xy to xi eta system, so we can now write like this one. So minus 1 to 1, minus 1 to 1, this is for xi, this is for eta, yeah, and then we can write this like this, b xi eta transpose of that j e inverse transpose of that, then we have D matrix, and then we have again j e inverse of that, then we have b xi eta, we got that, and then this one we have to, this one is, so you see there is a relationship between, this one is xy system, yeah, so we can also write here this xi itself is a xy system, and we have to this we have to transform basically. And how? So this one, what is the relation between the two? Well, we can look at this. So we have original system, which is goes like this one, yeah, so this is original system, xy system. So this is you say this is omega xy, yeah, so and then we are converting that into this system, yeah, okay. So here this will have, this one is omega xi eta system, right. So there is a relationship between the two, and the relationship is area. What is the difference between the two? Area is basically the you can actually say that a small area element, what is the relation between the area element here and area element there? That is the one which is the relationship between the two. So the relationship between the two coordinate system here, so the one is mapped, basically this is xi and eta. You may have already done during your engineering mathematics class, but this is how I view it as. So let us say in this domain, so we have, if you see here in this one, xi is changing and eta is not changing. So basically this one, along which one you can say that this is xi changing, right, and eta constant. Similarly, along this line and this line is equivalent. So you can say here this is xi equal to 1 simply, right. Here you have eta equal to 1, here you have xi equal to minus 1 at this line, and similarly at this, here on this one you have eta equal to minus 1. So these are the all constant lines, right. So eta equal to minus 1 on this one, the xi equal to 1, eta equal to 1, and xi equal to minus 1. So if you are talking about one small element here, let us say somewhere, say we are talking about here, right. So this one, if you are one element, a small element we are taking, and this is, let us say, d xi and d eta. So we have, say this one is from here to here, we have this is what we will call it d omega xi eta, right. So this is what the d omega xi eta is for us, a small one. The width, this will be say equal to d xi, and the height is equal to d eta, d eta. The equivalent, the element here could be something like this shape. Yeah. So, this will be something like this shape. So, we have that here. So, some shape something like this one. Now, here this is perfectly one rectangle. In this case, this will have this shape depending on the shape of this one. So, at here it will have this shape. Now, what is the relationship here? Only thing what we know is like this. So, here along which this one will be dn. So, you have n equal to constant. So, dn will be 0. Here we know d xi will be equal to 0. Here also dn equal to 0. Here d xi equal to 0. That is what it will be. Yeah. So, what is the relationship between this and this? We can find out here in this case, if it is x, the value of dx we can find out, right. So, what is the value of dx and dy, and then area of the two we have to compare what is the area of the two. So, here we like this one, right. So, what is the relationship between the two areas? Okay. So, here the area let us call it area 1. So, in this case area, let us call it area in case of xi eta system. So, say area A xi eta will be equal to simply d xi times d eta, we write like that. Yeah. Okay. In this case what happens? In this case we will have depending on the values. So, here we have this kind of system, we have like this, we have going like this one, there will be some angle, and then our area, the area A x y will be depending, this will be area for this quadrilateral basically, which will be equal to this dot this. So, whatever the line is here, vector we can represent that dot this one. So, we can say this is something like this, right. So, say 0, let us call A, let us call A, P and Q, let us say P and Q. So, this A x y will be nothing but O P dot O Q, right. Okay. And what is O P? So, the O P will be where O P, since this is we have x y system like this, right. This is x and y system. So, we have I and j, accordingly we can find out. Okay. So, our value here becomes like we have to first find out the OP and OQ. We can find out OP in terms of xi and eta, or say this OP will be equal to. So, let us say we have OP like this one, O2P, and let us say we have like dx and dy here. Yeah. Okay. So, we know that OP will be simply equal to dx I plus dy j. Only thing is we have to find out what is the value of dx. Now, dx as we know will be equal to del x over del xi d xi plus del x over del eta times d eta. Now, along OP, as we know, along OP, what is that? D eta equal to 0. See here, d eta equal to 0, right? So, if you like we are distributing such a way that eta remains constant along these lines. This is how we are slicing them, okay, so that we can relate this to this. If that is the case, d eta equal to 0, so d eta equal to 0, so what we get is simply this one, yeah. So, we get del x over del eta d eta, okay, that's what we get for this one. Similarly, for the dy, for this one, dy you can find out, okay. So, on the next page, so dy is equal to del y over del xi d xi plus del y over del eta d eta. Here del eta is equal to 0, we know that, right. So, what we get is simply is equal to del y over del xi times d xi simply, okay. Why? Because this is equal to 0, yeah, because this del zeta is equal to 0, that's why. Okay, so we got that. So, hence we can write that. So, simply we get OP is equal to del x over del xi d xi, then del y over del d xi. So, simply we will get OP is equal to dxi plus dy dyj is equal to del x over del del xi d xi I plus del y over del d xi j. Similarly, we can also write for OQ for OQ d xi equal to 0, not d xi, not d eta, yeah. So, similarly, we can, you will do the similar analysis, you can find out that OQ is nothing but is equal to, simply you can write similarly OQ will be equal to del, you have what you see x and y, so we will have x and y here also, only thing is we will have del eta, that's it. So, this will be del y over del del x only. So, del x over okay, so that we have see which one will be here, okay. So, basically here, okay. So, look here, so for this one del x, when we say this plus this equal like this one, and we know here del xi, the zeta equal to del z equal to 0. So, this will be equal to 0, hence we get del x equal to simply del x over del eta. So, we get del x over, so we have del x over del eta which will be I here, and here it will be del y, yeah, okay, fine, okay. So, then here it will be del y over del eta, then sorry del y, del eta only, yeah, del eta d eta j. So, similar to this one only. So, we have here also it will have a dx I dj. So, here we have in terms of eta only. So, here terms of eta only. So, we get like that one. Okay. Now, what is the relationship between the two? We have to find out the ratio, I mean the between the two, what is the relationship. So, relationship means the area. So, del x, the like area of this, we have to relate the area of the two, right. So, we have to relate the area of the two, and the area of the two are, in one case you have del this one is in one case, the other case this one is this. So, axy, so axy will be OP. Okay, area, the area we get not by dot, so sorry, there will be cross basically, yeah, so this will be cross. So, this cross this one, so that we have the area, and so OP cross product OQ, and what do we get? We get like this. So, OP is del x over del xi I plus del y del xi j, okay, cross del x over del eta I plus del y over del eta j, and then we have del xi and del eta. Yeah, okay, so we got that. Okay, so basically this a xy, what we get is basically this is equal to what do we get from here? We get, so we can write, maybe write on the next page, or a xy is equal to, we can have ijk. Okay, so we can write like that. So, we have x over del x over del xi, del y over del xi. So, the first one is del x over del xi, then del y over del xi, okay, 0. Second is del y, del x over del eta, and del y over del eta, 0. Okay, so what we get is determinant of that. Okay, so this is how we write. So, finally, this will be equal to simply del x over del xi, del y over del xi, del x over del eta, del y over del eta, and it is in the k direction. So, basically the k direction here we can drop basically. So, what we know that this is simply, this we know already, this one we had this del x, del xi, del y, del xi. So, let us see. So, okay, see here, del x over del xi, del y over del xi, del x over del eta, del y over del eta, and this matrix we call it a Jacobian matrix, but now we have determinant thing here. So, basically the determinant of this is basically determinant here. So, basically this is whatever we derived here is nothing but basically the determinant of the Jacobian matrix. Yeah. So, this one times k we are dropping. Okay. So, k a is a not a vector basically. So, so we can write like this as a k is equal to this one, or a x y equal to determinant of this, and also multiplied by, we also have d xi d eta multiplied, so not to forget that. So we have d xi and d eta, yeah. So this d xi and d eta, okay. So hence this we have this equal to d xi and d eta, but we know that this one is this is equal to like this one, and this one is nothing but the or you can say this is equal to j determinant of that, and this area of xi eta system. Or you can also write like d omega xy system equal to determinant of je multiplied by d omega of xi eta system. You can write like that. Okay, see, as long as you understand what the meaning is, you can write like that. So basically, what we have achieved is the value of in the stiffness matrix expression, the value, this one we wanted to write here, right? This one, and this one we can write it as this one. We know that this will be simply equal to j e, right, and then determinant of that, okay, and then we write d xi d eta. Yeah. So only to get this one we did lot of stuff there. Okay, so from page 13, okay, so 13, 12, 13, 14, we actually just was devoted to finding out this relationship. Okay, so now we have the final expression for k, and which is like this one. So the k will be equal to this B matrix as a function of xi eta, then this is the transpose of the Jacobian matrix multiplied by D, then multiplied by Jacobian inverse of Jacobian matrix. Sorry, this is transpose of inverse of the Jacobian matrix. So this is inverse of Jacobian matrix, then B matrix in terms of zeta, xi and eta, and then you have determinant of the Jacobian matrix, and then d xi d eta. So this is how k can be found, and the whole equation is the. Okay, so this is what we learned in this video lecture. So that is all for today.